Hello everyone, welcome to my presentation on advancements and challenges in cervical cancer detection, a comprehensive analysis of current practices and future directions in healthcare. This project has been guided by Professor Vaibhav Khatavkar and Dr. Swati Jaiswal along with the valuable contribution of my project team members. Let's begin. Introduction to cervical cancer. Cervical cancer is one of the major causes of cancer related deaths among women worldwide, particularly affecting women in low and middle income countries. Although cervical cancer is preventable and treatable when detected early, there are still major barriers like limited accessibility to effective screening programs, low diagnostic accuracy in some areas, and a lack of public awareness. These barriers contribute to late stage detection and poor outcomes, making cervical cancer a significant public health concern even today. Aims of the presentation. This presentation sets out to achieve three main goals. First, we will explore traditional screening techniques like pap smears, HPV testing, and visual inspection with acetic acid, that is VIA. Second, we will analyze how image processing, machine learning, and deep learning are revolutionizing diagnostic processes. Finally, we will highlight the current limitations and propose future directions for making detection technologies more accurate, scalable, and accessible, especially in underserved regions. Image processing based approaches. Traditionally, cervical cancer detection heavily relies on visual examination of pap smear samples by trained cytotechnologists or pathologists. However, manual analysis is not only time consuming but also prone to human errors and inconsistency. Image processing automates this process, standardizes evaluation, and enhances early detection by analyzing patterns, structures, and anomalies within the cell images. Why image processing matters. When diagnosing cervical cancer, cells often overlap and their boundaries become unclear. Variations in staining, lighting conditions, and sample preparation introduces further complexity. Therefore, accurate feature extraction, detecting specific characteristics from the images becomes critical to ensure precise and reliable diagnosis. Segmentation in cervical cancer imaging. In medical imaging, segmentation is the process of isolating regions of interest such as the nucleus and cytoplasm of cells. Multiple segmentation techniques are used like thresholding and region growing, which is basic methods based on pixel intensities. The next is active contours, also called as snakes, that is deformable models that capture object boundaries. The next is watershed algorithm and edge detection techniques, which are helpful for separating closely packed cells. Accurate segmentation directly impacts the ability to distinguish between normal and cancerous cells, which is a vital step in automated diagnosis. Handling complex cell structures. One major challenge in cervical cancer imaging is overlapping cells. To address this, researchers developed an enhanced model combining masked RNN with PointRend architecture. This model efficiently segments complex cells clusters and accurately detects cell boundaries even when cells overlap. As a result, classification of abnormal cells, whether precancerous or cancerous, become more reliable. Next is texture-based cervical cell classification. Beyond structure, the texture of the nucleus and cytoplasm also reveals valuable diagnostic information. Using the gray level co-occurrence matrix, that is GLCM method, spatial relationships between pixels are analyzed to detect patterns. Cancerous cells often have irregular and rough texture compared to healthy cells. Thus, analyzing texture patterns significantly boosts the model confidence in detecting abnormalities. The next is feature extraction using deep learning. Deep learning models add even more sophistication to feature extraction. Here, both shape, texture, and color features are automatically learned from the data. Since cancerous cells typically exhibit abnormal shapes, sizes, and color densities, deep learning models are well suited to capture these complex variations, helping in accurate stage and diagnosis. The next is optimizing diagnosis with hybrid techniques. An even better approach combines traditionally handcrafted features with modern deep learning. By using feature selection methods like principal component analysis, that is PCA, and linear discriminant analysis, that is LDA, we can highlight important features and suppress irrelevant noise. This hybrid strategy improves the model's ability to differentiate between low grade and high grade cervical lesions and also reduces the rate of false positives, making mass screening programs more efficient. Let's see the key insights and future outlook. Summarizing key insights. Image processing revolutionizes cervical cancer detection by automating segmentation, feature extraction, and classification. It offers high precision, consistency, and fast diagnosis. Looking to the future, there's no need to build larger, diverse, and labeled datasets to train best models. Develop real time, low resources compatible tools for use in underprivileged areas. Integrate these technologies into telemedicine platforms, making remote diagnostic possible and affordable. Now let's see the advantages and limitations. Let's discuss the advantages first. Early and accurate detection saves lives. Automation speeds up diagnosis and reduces human errors. Once deployed, image processing systems are cost effective and consistent across different settings. They detect subtle features often missed by the human eye. However, the limitations include dependencies on high quality images, poor quality significantly drops accuracy, difficulty in segmenting overlapping cells even with advanced techniques. Models may not generalize well across different populations or imaging conditions. Preparing large level medical datasets remain expensive and time consuming. Some complex models can be hard for clinicians to interpret and trust, raising adoption barriers. Thank you for watching this presentation. Cervical cancer detection is an area where combining healthcare expertise with technological innovation can truly save lives. Let's continue working towards making early detection universal, accurate, and accessible. If you have any doubts or thoughts, feel free to comment below. Thank you for watching.